Hey there, students. In this video, we are going to be talking about the other type of sequences, and that is geometric sequences. So we've already covered arithmetic, in which you add or subtract a common difference from each term. Now we're going to talk geometric. And a geometric is where you multiply a preceding term by a constant value. So maybe we're multiplying by 5 each time, or maybe we're multiplying by 3 or 1/2 or something like that. Now, I realize with the common difference, we kind of thought of it as either adding or subtraction. This one will only be multiplication. And technically, if you think about adding, subtracting is technically just adding a negative. And if I apply a similar logic here, multiplying and dividing are technically the same thing. Dividing is technically just multiplying by a fraction, right? So if I divide by 2, that's really multiplying by 1/2. Whatever you're multiplying by is going to be called your common ratio, or R. And if you need to find R, if it's not intuitive from the sequence itself, just take any term in the sequence and look at what came before it, divide the two, there is your common ratio. So let's see some examples, shall we? First one, I have 1, 5, 25, 125. It looks like I'm just multiplying by 5 each time, so that's my common ratio. Here, 4, 8, 16, looks like they're just doubling each time. So 2, if I'm multiplying by 2, is my common ratio. Here, two things are happening. One, my values are getting smaller, which means I'm multiplying by something less than 1. So expect the R value to be a fraction less than 1. And also, they're bouncing back and forth, positive, negative, positive, negative, positive, negative. So chances are my ratio will be a negative value. So to go to 9 to 3, 3 to 1, I'm dividing by 3 each time. Well, dividing by 3 is technically multiplying by 1/3. And if it switches back and forth, positive, negative, which means it's a negative 1/3. This is the same as saying divided by -3, by the way. But remember, we have to express these things in terms of multiplication. All right, so let's see some examples. We want to know, is this geometric? Meaning, can I multiply term by term by term by term? If so, what is the ratio? Here, it looks like it's multiplying by 2's, and it bounces back and forth, positive, negative, so that's legal. Our ratio here is -2. Here we have 3, 5, 7, 9. So I'm adding 2, adding 2, adding 2. Well, the fact that I'm adding, not multiplying, means it's not geometric. This would be arithmetic, sure, not geometric. 1, 6, 36. Let's see, 1 to 6, I multiply by 6. 6 times 6 is 36, so it's checking out. The 18, -6, +2, -2/3. Let's see, 18 to -6, I'm dividing by 3, but it goes positive, negative, so I'm dividing by -3. Divide by -3 again. So yeah, this would be, instead of dividing, right, it has to be multiplying. So instead of dividing by 3, it'll be multiplying by -1/3. And this one, to go from a 10 to a 15, let's see, if I did 15 divided by 10, what does that give me? 1.5. So that means 10 times 1.5 should give me 15, right? And then 15 times 1.5 should be 22.5, hopefully. All right. So my common ratio there would be 1.5 or 3/2. So now the moment you've all been waiting for. Here is the formula for geometric sequences. If you need to pause the video, which I would strongly advise you do, to write this down in a safe spot, that would be in your best interest. So the explicit formula is to find the nth term. You'll take the first term times the common ratio raised to the n minus 1 power. Now, just like we had with arithmetic sequences, this exponent will always be the difference between these two subscripts. So that's going to come into play if maybe we don't know the first term, but we have like the 9th term and the 3rd term or something like that. Then this would just be 9 minus 3 or 6. So something to keep in mind when we cross that bridge. All right. Here we go. We want the explicit term. Oops, hold on here. I forgot to actually have the example in there. Give me a second. There we go. Much better. All right. So we want to know what is the explicit formula if the ratio R is 1/3. So we're given the ratio, boom, 1/3. That's going to come into play. And then the first term, A1, is 6. Cool. Hey, what the H, whatever. All right, so all we have to do is just plug in what we know. 6 times 1/3 to the power of n minus 1. That's as nice as it's going to get, so we just leave it. Example 3. Given the following sequence, we want to find the 15th term. All right, so I know my first term, right, is -3, and I'm multiplying by 2, by 2, by 2, but it's oscillating negative, positive, so my ratio would be a -2. Now, if I wanted to find the 15th term, I'd have to plug in 15 for n. So -3 times -2 to the 14th power. All right, well, if I do that, that's definitely a calculator work. This is what I would get. If you're plugging this in a calculator, which all of you will, make sure that you are using your parentheses responsibly. If you don't have parentheses, you might screw up on a negative. So that's something to keep in mind. Onward we go. All right, example 4, part A. 18, 6, 2, and 2/3. We want to find the explicit formula and find the 8th term. Well, my first term is 18, and then I'm dividing by 3 each time. Dividing by 3 is technically multiplying by 1/3. So my explicit formula is 18 times 1/3 to the n minus 1 power. To find the 8th term, I just plug in 8 for n. So 8 minus 1, that's 7. 18 times 1/3 to the 7th power would give me 2 over 243. And let me just show you guys how we would punch this in to get our fractions in case some of you are unaware. I type in 18, open parentheses, scooch this up, 1/3, 1 divided by 3, to the power of, that was 8 minus 1. I can do that in my head, right? That's just 7. This is going to spit out a nasty decimal. If I hit math, option 1 is frac, convert to a fraction. There we go. Cool. And I say that because MathXL might not like decimal answers on a quiz or test. I would certainly prefer this over this one here because you're going to have to round that at some point. And if you round, you lose accuracy. Okay. Next one. I've got 2/3, 4/9, 8/27. Just like we did in previous lessons, kind of isolate what are the numerators doing and what are the denominators doing. So treat those as kind of two separate sequences almost. 2, 4, 8, multiplying by 2 up top. 3, 9, 27, multiplying by 3 in the bottom. So I'm multiplying by 2 over 3, 2/3. So here's my explicit formula. I would plug this into my calculator, finding the 8th term, 8 minus 1, so that'd be 7 as the exponents. Math frac your answer. Boom, done. Now we might see problems where maybe we don't have all the information we need. Maybe we don't know the ratio, and instead we're given 2 terms. We've seen these with arithmetic, why not with geometric, right? I know the first term, so I know A1. I don't know R, so I need to figure that out. But I do know my 4th term, right? First, second, fourth, third, fourth. My 4th term would be 36. So here's the information I have so far. Now, if I started at the first term, I would have to take 1, 2, 3 steps to get to my 4th term. So my R value will be raised to the 3rd power because I had to take 3 steps, basically the difference between the subscripts to get there. So I plug in my numbers, 36 equals 972 times R to the 3rd. Divide 972 over to this side, and I get 1/27 equals R to the 3rd power. To get rid of a 3rd power, I take the 3rd root. So my common ratio is 1/3, and that makes sense, right? My common ratio should be a fraction less than 1 because my numbers are getting smaller. So now that gives me enough information to write out my formula as 972 times 1/3 to the n minus 1. And if I wanted to figure out these missing terms, I know I'm multiplying by 1/3, so 972 times 1/3, or divided by 3. And then take that times 1/3, take that times 1/3. All right, let's see a similar one. Same idea. We know the first term, we know the 4th term. So take what we know and plug those into our formula. Starting from the first term, take 3 steps to get to the fourth. So plug in what you know. Divide 12 to the other side. Negative 3 halves divided by 12. Again, you can use your calculator for that. Would give you a negative 1/8. Now we're going to take the third root to get rid of a third power. I'm already anticipating a negative R value because it's going positive and ending with a negative. And I'm anticipating something that's less than 1 because our numbers are getting smaller. My R value is going to be negative 1/2. So now if I wanted to find the in-between values, I would simply just multiply by negative 1/2. So this would be a negative 6, positive 3, negative 3 halves, so on and so forth. All right, next up, the third term of a sequence is 250. The 10th term is 125 over 64. Gross. Let's see, if I go from the third to the 10th term, that means I'm taking 7 steps to get there. So I'm already anticipating an exponent going to be 7, right? Because 10 minus 3. So let's take a look at what we know. I know the third term, know the 10th term. So to get to the 10th term, I start at the third term and multiply 7 times by my ratio. Plug in what we know. Use this now to solve for R. So 128 equals R to the 7th power. We'd have to take the 7th root, in case you guys don't know how to do that. Calculator. So I'd type in 7, math, down here to option 5, the xth root. So that's going to give me the 7th root of 1 over 128. Boom, boom, boom. Enter. 0.5. If you don't know what that is, math bracket, but that's 1/2. Come on now, people. Our ratio is going to be 1/2. So now I've got all the ingredients, right, to write my common or my explicit formula. Oops, actually, I jumped the gun. My bad. We don't have all the ingredients because we don't have A1 just yet. But what we do know is that my third term was 250. Now I could do some algebra to get the first term, or I could use the fact that moving forward, I multiply by 1/2. That means moving backwards, I'd be multiplying by the reciprocal, the opposite, 2 over 1. So 500 would come before this, 1,000 before that, right? Because moving left to right now, I'm multiplying by 1/2. So that would give me A1 is 1,000. So my explicit formula is 1,000 times 1/2 to the n minus 1. And I don't think we had to figure out any specific terms. Nope. Cool. All right, last and final one. This one's going to get a little bit gross just because we have fractions and notation. But the process is the exact same as what you've been seeing. 9th term is 1/2. 12th term is 1/16. Take a look at what we know. I'm already anticipating an exponent of 3. That's the difference between the subscripts. So to get to the 12th term, start at the 9th, times r to the 3rd power. Plug in what we have. I know my 12th and I know my 9th term. To get rid of this 1/2, we'd have to divide by 1/2, which is technically multiplying by the reciprocal, 2 over 1. So r to the 3rd power is 1/8. That means r is 1/2. Great. I know the r value. Now I need the A1 value. Well, to find the A1 value, I could use the A9 value, right? To get to the 9th term, start at the first term and multiply by 1/2 to the 8th power, right? To get from 1 to 9, I have to take 8 steps. Numbers are going to get a little gross here, sorry. So 128 would be my first term. To get rid of this 1 over 256, multiply both sides by the reciprocal, 256 over 1. My explicit formula is then going to be 128 times r to the n minus 1 power. So that one was a little bit more gross, but the process is the exact same for all of these. So there you have it. There is finding explicit formulas for geometric sequences using this lovely formula. You know the drill, folks. If at any point you have questions, please let me know. Good luck, have fun, be safe, Roll Tide.